Okay, so now I have a link on the website that I want to show you. Okay, so on the website, inside the parametric polar, April 30th, in the red section, there's a link that's going to help us try and see these things. Okay, so I'm in degrees, okay, just because it helps you see stuff better. So I'm in degrees. And we were talking in between videos here that if I change the A, stuff seems to grow. I'll make it bold. If I change N, lots of looping or petals. And if I change B, it's me walking through drawing the polar graph. Okay? And this is an advanced one where I have A is 2.6 and N is 6. But the thing I want you to notice is I kind of mentioned on video 1 that I'm going to call blue chompers positive radiuses. I'm going to draw red chompers as negative radiuses. Your brain naturally likes blue and despises red. Even though it looks beautiful there, the red is the hard thing to understand. So I'm going to go back to the one we first started with at the end of that last video. We had something like 3 plus cosine theta. And then I'll start back at 0. As I chomp, I'm showing you the chomper. These are the chompers. They're the chains. And the dot is the mouth of the chomper. All of these are positive radiuses. This is what your brain wants. That you go around counterclockwise, positive radiuses, and you collect quadrant 1, 2, 3, 4. And then the one that almost caused the doozy is 3, because here, positive radiuses, but right here, this issue, right at 180, notice how I plotted the point, 0, 180. What's the 0 mean? Radius. What does the 180 mean? Angle. So I'm looking due west, but my chomper's not going out. So it's stuck at the origin. And then from there, I go back into the positive radiuses. So like here at random angle 237, my radius is 1.36. Cool. Now, this is the one that we didn't like. Okay, if I have a 4 there at 180, 3 plus negative 4 is negative 1. So I want to look due west. But if you look due west from here, like right where my pointer is, I'm trying to look due west. Is there any chomper over here? On the x-axis going left. There's no chomper because I flipped. So look what happens with my radiuses. Here we go. Positive, 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 positive. All this is grand and dandy. This one should make sense. What happens at 90 with cosine? Cosine of 90 is 0, so you good that it's really just 3. And can you see that down at 270? Down here, it's also just going to be looking down south at 3. But here I go, swooping, oops, swooping, swooping, swooping. Right here, I go negative. And now do you see my point? The point is at angle 166, I'm looking backwards at a negative 0.88 radius. So look how I make the loop. It's all a negative loop. That's why it's a red radius, because I'm actually looking backwards. Then when I pop out of that loop, I'm back into the positive world. You guys okay with that? Okay, so now let's go to the original one that I first asked about, the very basic. Do we have a 6 on it? Or is it just cosine? 6. Okay, so I have a 6. Okay, and my first question I prompted this with is, if your radiuses are all positive, which quadrants are you in? All of them. Am I in quadrant 2 and 3? Like physically, am I over in 2 and 3? Like up here? Am I up here? No. Am I down here? No. Which means I have to have negative radiuses. There's an issue because I'm not collecting all 4 regions. So look what happens. Positive, 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 right to 90. Now, where am I expecting to go? You already know where my picture goes, but visually before you even drew it, where are you now looking at? The northwest region of the sky, and you want to look at the beautiful sunset. Okay, you're looking in that second quadrant like saying, show me! And look what happens. Between 90 and 180, ready? 90 and 180, which is the second quadrant, I'm all backwards. Like that should really be looking, oh, I have my cord. I can't get over there. It should really be here. I should be going out at the angle of 141. And I'm just going which way? Backwards. And I do that to 180. Now what? What region should I now expect to be in? Third quadrant. So I'm expecting to see bottom left. I'm looking in the bottom left region. So like if I did this, I'm looking in the bottom left region, and as I go from 180 to 270, do you see how I don't see anything in that third quadrant? It bugs me. Do you guys see that? Which means it's there. Where is it though? Yeah, so look here. If I go from 180 to 270, I should have been in the third quadrant, but I was backwards. Do you see how that fanned it red again? Then I'll zoom in on the fourth quadrant. I'm expecting fourth quadrant. Come on. Oh, good. And I get fourth quadrant. And which color is it? Blue. Are you guys okay with that? Now, I got another app that you might go like, and I'm going to show it to you. Okay. How does 6 cosine theta trace out? Now watch this app. This one, mind-blowing. Okay, I'm going to type in 6 cosine x. Notice how I typed in x. So what am I graphing for you right now? Rectangular. This is very key for you to notice. I'm graphing rectangular. And I want to really graph. What do I really want to graph? Polar. So I really want to make it look like, you guys go with that? That's what I really want to graph. But I'm going to show you how to translate from rectangular visually to polar. This is, when I saw this on Twitter at like midnight a year ago, I was like, saved it immediately, threw it in my little file system. Like, I can't wait for this day right now in Calc 2 in 2019. Yeah. Okay, I think I witnessed it like June 1st last year, and I'm like, I have to wait like 10 months before I show this to someone. So I didn't show Matthews, so I should bring him in here. Okay, here we go. This A will help you translate from rectangular to polar. So this is really trying to represent the polar, but I'm drawing it in rectangular first. Now watch. Now, I need you to stare at some of these pieces. So, first dot, where's the first dot going to go? This first dot, where's he going to translate to? To the 0 angle. So just look at the first dot for now. Just look at the first dot. Do you see how he goes all the way to angle 0? He started at a height of 6. So then when he goes to angle 0, he goes out to that height. Good with that? Next one that you should look at, that dot. You know that dot, that's pi over 2. Pi over 2 comma 0. Pi over 2 is angle 90. So I'm going to have that dot go straight north. It's looking north, but what's its radius going to be? 0. So watch this dot right there, this dot, and it goes to 0. Because it's really looking north, but it has no radius to it. Okay, next one. This one. Where am I looking? 180. So I'm looking due west, looking left. I'm expecting to be out there. But what's the radius? -6. So even though I want to look left, it actually goes right to the backward 6. So watch that dot right there, and it's going to land back over here. Because it's a negative radius. So, what pieces make a loop? Before I spin it, give me some pieces that make a loop. Which parts of this picture make a full loop? 0 to where? To pi. Okay, so now look at the collection of those dots there. And does that section? It does. And then over here, this to there, those are going to make the second loop. And you can kind of see it like looping upon itself. You guys okay with that? So I'm going from here. Let me snip this. That. Helps me morph into the circle. You guys good with that? I got a couple more. So this one. Yeah, James, question. Because, good question. Okay, let me hit pause so I can get out of. Okay, here's the question. I get that 0 to 360 on unit circle makes a full loop. I don't get how 0 to 180 makes a full loop here. Okay, so highlighting it now that I'm back on my board. Highlighting, I'm telling you that this and that animation created one loop. So what happened was first dot went to here, and as I go, okay, where am I now on the regular rectangular form? Like I should almost, let me break this down a little bit even more. Okay, that's that piece. Okay, and the two extremes are, this is at 0, 6, which translates to what? How does it translate when I actually flip it into polar? Angle 0, radius 6. So do you see how it goes to 6, 0? Okay, and then this dot here is from this dot there. That dot is at, we'll do pi over 2, comma 0, which translates to 0, pi over 2. You guys okay with that? This is already kind of in James's question. James asks, okay, 0 to 360 makes a whole loop. 0 to 180 should make half a loop. And already I'm almost contradicting James, because now, do you agree, I've only gone 0 to 90, but I already make half a loop? Because where am I centered? Here's the key. I'm not centered on the origin. I'm attached to the origin. Yeah. Okay? I'm not centered on the origin. If I'm centered on the origin, I am getting what James wants. 0 to 180 is half of the story. 180 to 360 is the other half. But I'm not centered at the origin. I'm actually only on the right side, and since I'm only on the right side, is quadrant 1 half of the right side? So once I go through 0 to 90, I've collected half of the right side. That's half of the loop. So the big difference is you got to be careful about being centered at origin or being attached at origin. Okay? James's comment was kind of about, I get that this makes a full loop. That's because you're centered at the origin. But how can you have something else make a full loop when you're only 0 to 180? Or here actually 0 to 90 made half a loop. It's because I'm attached at the origin, and 0 to 90 is the first quadrant, and that is half of the right side. Okay? Woo! So now I want you guys to try and look at this one. Try to graph this in rectangular first on paper, Then in your head, translate it to polar, and then